In my prior videos, we built the breadboard computer clock module with the Alchitry I/O board, and that board was mounted on top of the Alchitry Au FPGA board. Well, this is a breadboard computer project after all, so there hasn't been a lot of breadboards in it. So I want to remedy that with this video, leading to completion of the clock module itself. So what I have pictured here is it's called the Alchitry Br board, and this is basically just terminates the pinouts from these connectors on the board to 0.1 inch pins. So ultimately, this is what we have to be able to hook to a breadboard. It's not exactly ideal, but that's what we're going to try. So I started, let me see if I can turn this correctly and get a good view of it. Yeah, there we go. So I started putting 254 millimeter pin headers on here in order to be able to plug a ribbon cable in. And so I don't know why, but I had a particularly difficult time soldering these things. You can't really see from this view, but I do have a camera that gets a little closer on these solder joints, and you can see it's generally okay, but then there's one right there where it's probably okay, but that one doesn't look good. And then that one in particular, this one up here, if I can get, yeah, that one right there looks like it could be cold. And there was another one, it seemed like over here somewhere. Yeah, that one right there. So anyway, I'm going to go back and go over these a little better, but just a warning, if you do this yourself, take care with soldering and be sure to heat the pad. The problem is the pad, look at that. The pads are just teeny tiny. I'm not sure why. I think SparkFun did this. I don't know whether they took Alchitry's design or they did a new design, but anyway, those pads are just teeny tiny. There's just no reason why they should be that small. So it's going to take a little patience to solder this up. I plugged into a 40 pin, that's essentially a 40 pin IDE cable, but it's part of a Raspberry Pi breakout module that I just had laying around. And I can envision making something like a BR board, let's say, that allows you to plug in cables like this that terminate into a breadboard so that, this thing can be much more breadboard friendly, which, it really kind of is. They say that this BR board is supposed to be a breadboard, but I don't see how you easily do that. So in any case, I did a pin mapping of the Raspberry Pi breakout because, of course, that doesn't have the AU numbering scheme on it, so it's difficult to know what's what. So, and I'll put this on the video and on the on Google Docs so that you have it. But I had this SCL pin on the Pi mapped to the AU pin B27. So therefore, let's flip over to some code. And I created a new project, a blank project based on the base project. And then I created my own constraint file. I called it Pi breakout. And in that, I added pin B27. I just called it my LED. And then up on the top, I added an output for my LED, created a counter of size 1 and had it overflow at 2 to the 24th. And then referenced my LED to the value of the counter. And as you can see, the LED is flashing. So I know that I've hooked it up correctly and I've got things soldered correctly and I have power. And by the way, you can see that I have power, and this is 3-volt power going to this pin and also going to that pin right there, and set, per the sheet, per this sheet right here, we can see that the MI pin has got V plus and there's a couple of grounds. So I kind of know my proof of concept for breadboarding works. Now I'm going to hook up some switches and LEDs for the clock module on the breadboard so that we now actually have a clock breadboard module. So I've now got the clock module installed on a breadboard because I did some more cleanup to make this really what I wanted it to be, which is a top module that has very little in it. Let's go there and look at it. So I took out, since I took off the IO board, I took out all of the IO constraints that were exposing the buttons and all that stuff, and I put in my own. And actually, I'll go ahead and open that up. So there was an IO.acf file, that is a user constraint file that's put in as part of the project. When you create a project, if you select based on the IO element board, all I did is rip that file out. I just deleted it, and I inserted my own naming and pins that I have the switches and the LED plugged into in this file. And so then back in top, any reference that you had to the old IO pinouts, I just deleted. So like IO cell, IO LED, etc. I just deleted them from this module and then inserted the signals from the BRACF file right here at the top. So I'm not going to go through all of this, but this file is now very simple. The only thing it does is it wires up the clock signals to the input-output signals that come into the module. So it's very clean. All of the implementation-specific stuff related to the clock is now in its own, actually 2 modules. So one thing that I will mention is, before, where I just had a type of clock or a module of clock, now I have another module called Clock Digital FS. And so the reason that I decided to do this is because the basic function of the clock is fine. However, the way I had implemented it, unlike what Ben had done where he had a potentiometer, I have a fast button and a slow button, basically digital signals that signal to the clock module to speed it up or slow it down. The AU board has analog capability, so in theory you could hook a potentiometer up to it. I've gone through some of the notes. It's actually not well documented in the Alchitry write-ups yet. They probably will get to it. There are few folks that have posted to the forums that talked about how to do it. I wasn't really interested in doing it at this time. But what I did do is build I always want to say class. I built a module that implements the digital fast-slow functionality. So I've added a faster, slower input, carried over all of the other clock signals, implemented the clock module here, and then basically passed all the clock signals through, and then implemented the faster, slower bit of logic that I used to have in the top module, but I've now implemented it here. In this way, if you wanted to switch over to a potentiometer, what you do is you just say, clock pot FS, and instead of fast or slower, you would hook up an ADC input and wire up the potentiometer to that ADC input, and then everything else would stay the same. Auto manual indicator is low. That's actually what this brown wire is right here. It's tied to ground right there, and so the middle button here is the manual advance, and so that's working fine. So let me tie the auto to high. So now we've got the clock running, and we can speed the clock up with the speed up button, and we can slow it down with the slow down button.